Good morning and happy Friday! Let's talk about slots and how they enable us to reshape the DOM by gathering nodes and opening skylights in them. But before we discuss how to use them, let's reflect on what they are. Please join me in closing your eyes for a moment. When you hear the word slots, what comes to mind? Recall the times in the past that you've used slots, and the times that you've used props. What experiences informed these decisions? Okay, you can open your eyes again. For today's talk, I'm going to focus on using slots as receptors for visual content. In other words, what's only in the template tag of a single file component and not the script. But what is a receptor, you might ask? Well, this is a term I've borrowed from biology to refer to a container designed to receive content and integrate it either into the container itself or a larger system that the container is a piece of. In short, by using slots, one component can communicate with another by enveloping and injecting templates into it. So let's talk about the different types of slots. There are four: our default basic starter slot, name slots, scoped slots, and finally teleporting slots. Let's start with default slots. Imagine your app, a house, has imported a room component with one slot, which will be represented by this chair. Now we can insert any elements we want into the room, and they'll be automatically placed in the chair. So if I move M into the room, she'll be placed in the chair. We can also specify content for the slot to be preloaded with, which is known as default content. So if I specify that Jason should be seated in the chair by default, and then don't pass any data into the component, the chair will render with Jason in it. But if I change my mind and decide to move M in there after all, she'll replace Jason in the slot. But what if there's more than one slot? What if the room component has two slots? If I were to place M now, how would the compiler know where she should be seated? I suppose it could guess, but what if it guesses wrong? And also, what if I pass in Jeff? How would the compiler know if they should go in the same seat or disparate ones? That's where name slots come in. By assigning each chair a name, we can send M and Jeff directly to their respective seats. So far, we've looked at the ergonomics of placing content in the slots. But what if we want to augment the content itself? Let's look at a room component that has a slot for a pianist. Suppose on special occasions we want them to be wearing fancier dress. Well, changing the appearance of a slot's content is a snap with scope slots. To expand on that idea further, let's look at a kitchen component that receives an array of groceries. We want to ensure that each grocery... Do I ever use that singularly? Anyway, we want to have each item sorted in an appropriate manner. We can change the way each item is handled using scoped slots. Note, though, that scope slots are different to the other types of slots in terms of their scope of ownership, which is incidentally not related to why they're called scope slots, but we'll talk more about that later. Finally, here's an example of the fourth type of slot, teleport slots, or as I like to call them, teleportals. These are unique from the other slots in that they allow you to subvert the DOM by wrinkling the node's hierarchy. For example, I can use teleport to pass soiled laundry from the reading room upstairs to the laundry room in the basement. Now that we've gone over the look and feel of all of the different types of slots, let's talk about when and how to use them in code. For the next few examples, we're going to be looking at a social service known as MyPlace. MyPlace is a simple site that doesn't believe in imposing much structure on its users, which is why its most basic layout is a free-form container where users can store all their stuff. The starting template for a MyPlace looks like this. On the right is a template for the foundational base place component that all MyPlaces are created from. It currently has one slot with no options, a default slot. Notice also that I'm interpolating place name at the top from the props. The difference between props and slots is that with props, the child owns both the data and the DOM context or visual framing of the data, whereas with slots, they are divided and the parent owns the data and the child has the framing. Also, because the parent doesn't necessarily know the inner workings of the child, I've represented the child with a dark theme, as opposed to the light theme of the parent. Throughout this talk, I'll be using the light theme to represent the parent, consumer, or user of the component that has a slot it wants to fill, and the dark theme for the code in the reusable child receptor component. And in case you're wondering why these examples are sometimes missing that classic single root element, I've not only simplified some of the markup, but I'm also using Vue 3 for these examples. While most of the examples we look at today should work across both versions, small details like fragments and array mutation may be different to what we're used to. And of course, teleport is new in Vue 3. Going back to the consuming code on the left, you can see my MyPlace page, which is empty right now except for that basePlace component which I've imported. Now any content I put inside basePlace will populate the slot. So if I fill it with food and we look at the UI to see if anything's changed, voila, there's food. But beyond my MyPlace's default clever name, how can I let other users of the site know which page is mine? Well, what if MyPlace had a second slot where I can post information about myself? We could add a second slot for an about section in basePlace. But now that we have two slots, we're going to have to name one of them so that the compiler can tell which content goes in the about section and which goes in my main area. See how on the right I gave that first slot the name about? Now on the left, anything I put into the template with the directive v slot bound to the name about will go inside the about slot, while anything outside of that will go inside the second default slot. We could also specify the default slot in my MyPlace code if we wanted to be extra explicit, and I suppose we could explicitly name my default slot, which is named default by default, if we wanted. And as with all slots, we can specify default content for what the slot should show if we don't inject any content. For example, I've put 3 bananas inside basePlace's default slot on the right and removed all visual content not going in the about slot on the left. So what do you think we'll see in the main content area now? That's right. Since we didn't pass in any food, the main section was populated with our backup content of 3 bananas, or bananae. So why are slots useful, and when might we want to use them? Well, slots are great for situations where we want to replicate the same visual framing around different types of content. In other words, when we have consistent outsides and variable insides. However, it's important to keep in mind that the parent owns the data and the child owns the UI context, and that provided content replaces initial content. Some examples of components that might be appropriate for the base use case of same skin, different guts include buttons, layouts, and modals. And with that, let's move on to teleportals. So here are 2 more MyPlace pages. You might have noticed that Jason completely copied my MyPlace hashtag content, whereas Matan has customized his to be a veggies only club. What you may not know, however, is that Jason is a mischievous guy with a top secret up his sleeve. But more on that in a minute. Here's the code for the MyPlaces we were just looking at. Jason and Matan are both passing a profile pic and pronouns to their about sections, and the foods of their, or in Jason's space, my, choice to the main area. Let's see what that looks like again. Just kidding. Remember Jason's big secret? Are you ready to see what it is? So if there's one thing that Jason's passionate about, it's bananas. Because of that, he secretly added a button to his about section to send bananas to the banana dimension, and snuck a portal from there into Matan's veggie garden using teleport. The way he accomplished this was by adding a DOM element with the ID the banana dimension to be his teleport destination inside Matan's main area. In his case, Jason used a div, but destinations can be any kind of element, even templates. Back in his own MyPlace page, Jason wrote out the nodes he wants to beam into Matan's garden, in this case as many bananas as there are times he's pressed the banana button, and then wraps them inside a teleport tag with the banana dimension selector as his toValue. Let's see if this works. There are so many bananas in Matan's garden. Bananas aren't veggies! Matan would be so mad when he saw this if he didn't know of a way to big brain out of it. But before we can see Matan's turnabout, we need to discuss what just happened here. Here's a rudimentary representation of what the DOM and VDOM look like in MyPlace. So at the top we have our root Vue app component, which has 2 children, Jason's space and Matan's veggie garden. Each of those also have 2 children, the main and about sections. And in Jason's case, his about section has another child component, the banana button, and his main area has an origin teleportal, while Matan's main area has a destination teleportal. But what happens to the hierarchy when Jason sends bananas over? Basically, If this represents the origin in JSON space, and this represents the destination in Matans, when JSON hits the banana button, the nodes sent to the origin wrinkle the 2 points together such that they're now the children of the destination. This is a bit funny though, in that while the bananas are JSON's children as far as the view DOM is concerned, at least for data, they're Matans according to the actual DOM, as well as potentially for styling. And because that destination frame is still Matan's child in any case, it can override the style of teleported nodes. It's this knowledge that Matan's leveraged to transform JSON's bananae into something he finds more palatable. Are you ready to see what that is? Let's see what happens when JSON tries to send Matan bananas now. They're all tomatoes! Matan, how did you do that? So the key point Matan took advantage of is the teleportal destination element being inside his garden. Because everything sent to the banana dimension will be wrinkled into descending from that node, Matan can restyle the bananas to look however he likes as he receives them. But remember, slots are superficial. These may look like tomatoes on the outside, but they'll still taste like bananae when you bite into them. Another interesting thing to point out here is the inverse dynamics of props and teleport. With props, the child handles mutation, placement, and styling of the data, whereas with teleport, the parent handles mutation, placement, and unless the child destination overrides it, styling. So, Jason and Matan have both had their fair share of fun, but night has fallen once again in Toronto, and as much as Matan likes the color yellow, he'd really like to have his garden restored to its original state before he goes to bed. So Jason adds a disabled attribute to his outgoing end of the portal. Watch what happens when Jason pushes this change. Not only are the bananas now in JSON space, but they look like bananas again. This is because the bananae, being a descendant of Matan's garden, are but a stylistic wrinkle in space. Whether teleported or not, they're still, as far as the view component tree is concerned, descendants of JSON's page, data-wise and style-wise. In other words, the disabled attribute determines not only where teleported content gets rendered, but potentially how it gets rendered as well. Now, the eagle-eyed among you might have noticed that in the code snippets of JSON space that we've looked at so far, he has a v-if set to bananas on his outbound teleport node. What's that all about? Well, bananas is the variable he's using to keep track of how many bananae to send Matan. And so if he doesn't have any bananae, he doesn't teleport anything over. So far, we've only looked at situations where we started from 0 bananae. But what if we wanted to start with 1? Now, when we load Jason's and Matan's MyPlaces, we get a warning. Failed to locate teleport target. The target element must exist before the component is mounted. It also looks like the target was loaded as null. Jason, ever the adventurer, throws caution to the wind, however, and sends a banana anyway. And gets the error, can't access property parent node, node is null. If only we had a way to see this coming. But what just happened? Remember, slots are superficial, and element renders are bashed together using nexttick. So if the slot content is a DOM node, and the teleport destination is also a DOM node, and they're both in the same render queue, meaning the teleport destination doesn't exist yet, how will the compiler know where to send the banana? You may have seen a recommendation in the docs to place teleport destinations outside of your view app, and my understanding is that the motivation there is to help avoid situations like these. Now that we've had our fun with teleport, let's talk about what they're good for. After all, if my guess is correct, and I'm not half bad at guessing, none of you are doing a lot of banana sending right now. So when is teleportation useful, and why might we need it? Well, teleportals do and don't care about hierarchy. They don't care in that they can be rendered at any point in the DOM. They ambivalently care in that an outbound teleportal maintains a connection to its view parent for data reactivity and styling. And they do care in that their appearance can still be overwritten by the destination teleportal. To sum it up another way, compared to other types of slots, teleported content can be rendered to relatively stable endpoints orthogonal to the DOM's current shape. This is great for moments when you need a component that stylistically lives under a rock. In other words, you need it to render in a certain spot or in a certain way no matter what. For example, toast notifications, tooltips, and modals. However, as a design aside, I'd like to challenge you to think of alternative ways to popovers to solve these problems that these UI elements have become catch-alls for, and also to think of creative new ways to use teleport. Speaking of which, so far the way we've looked at and used slots has been visually pretty one way. What if we wanted to send content both ways? In other words, a bidirectional teleportal? Well, for that next use case, we need to keep in mind one more aspect of teleportation. Unlike the previous slots we've looked at, when it comes to teleport, new content gets appended to old. So here we have a house full of hungry folk all yearning for some fat stacks of pancakes. Manish, Bobby, and Em can all let Jeff in the kitchen know that they want pancakes using a teleportal. Notice how when multiple outbound teleportals target the same destination, the sent nodes render in temporal order. This is behaving essentially like a device called a dumbwaiter, which I'm going to instead refer to as a food lift for the rest of the presentation, because that's what it is. A little elevator that connects multiple rooms to a single destination, the kitchen. And the code looks something like this. In the pancake house on the left, all 4 rooms are siblings, and on the right, the kitchen component contains the food order's teleportal receptor destination. All non-kitchen rooms have a button that teleports orders for pancakes to the kitchen. Now, because this data is the domain of the user component, in this case the non-kitchen rooms, the component teleporting the order knows which room it's teleporting orders from. So, for example, because Bobby's room is responsible for the data in Bobby's outbound teleportal, everything that he teleports over has access to the data in his room. But the thing about food lists is we don't usually think about them with regards to sending things to the kitchen so much as getting food from there, and I'm pretty sure everyone would love to get the pancakes that they've ordered. But how can Jeff send the pancakes back to each room? Maybe he can look at the name on each order and teleport the pancakes back by name? No, that won't work because remember, slots are superficial, meaning Jeff only has access to their content in the template. So what if the orders emitted custom events with the room info? Well, the orders are still the children of the bedrooms, which means that they, not the kitchen, will get the info, and they don't need it. But hang on. Remember that with slots, the child has the framing, but the parent has the content and the data. In other words, we have everything we need to send pancakes back within the parent bedrooms themselves, meaning that, for example, when Jeff clicks Em's order in the kitchen, Em's room can take care of the data side of serving her a pancake. Let's see what that looks like. Now, conceptually, this might be confusing because it visually looks like Jeff is sending Em a pancake, but we know in the code that Em is taking care of it all on her own. In this way, teleported slots can feign being two-way, despite the data never leaving the parent bedroom. And this possibly serves as a good reminder that sometimes a UI problem might be solved more simply than where our impulses initially lead us. But what if after all this, we still want an actual, factual, tangible reverse teleport? That's totally possible also because remember, teleport is irrespective of the DOM. So let's add an outbound teleportal from a secret location in the kitchen that will target a selector of the bonus pancake class, which will be installed in every bedroom. So now all of those rooms have a teleport receptor with the class bonus pancake, and the kitchen has a teleporter that targets that class. When Jeff presses the secret button, who will get the bonus pancake? Manish does. Well, why is that? This is because Manish's room has the first instance of the teleport target in the DOM tree, and true to its name, teleport sends nodes, doesn't clone them. In other words, you can't teleport to more than one destination at the same time. That's why it doesn't matter how many bonus pancakes Jeff flips. Manish will get every last one. But enough eating. It's time to do some laundry using scoped slots. Everyone dumps their soiled clothing into the laundry room because while folks may disagree about how they'd like their clothes to be cleaned, they're all pretty much in agreement that they'd like them to be cleaned. Hang on, rewind. It looks like all the clothes were being sent to the laundry room via slots, as per all our previous examples, but this time it's different. We're rendering a list. Wouldn't it be more effective to send the data through props, in other words, through JavaScript? Let's do that instead. It might be helpful to think of this as passing data behind the scenes, because the laundry room will receive the props before it's time to mount and render the template. Great! Now everyone's dirty clothes are in the laundry room. Time to sort through it all. So, Jeff wants to put all machine washable clothes in the washer immediately, whereas Solly sends all of their laundry to the dry cleaner. Meanwhile, Em checks that the washer is actually on by ensuring the clothes are wet, and whenever John finds clean clothes in the washer, he hang dries them to conserve energy. Here's our starting point. All the clothes are passed to the laundry via props, which cycles through and renders them all. A key point to note here is that unlike with previous examples, we're not passing visual content, but JavaScript data, in this case the laundry array. This means that in theory, the items populating the laundry can be of wildly varying shapes depending on the user or parent component. Anyway, this code gives us something like this, with all our clothes in one unsorted clump on the left. But we can do better, can't we? Let's separate our clothes into those that can and can't go in the washing machine using a VIF directive. There. Now any clothes that can go in the washer are in the washer. But this isn't quite a convincing look, is it? The clothes we've just moved are looking a bit stiff, don't you think? Well, what if we add an additional check for whether the item is clean or not? And if it isn't, we'll swap out the default clothing image for a wet one, and if it is, we'll hang it up to dry. Now our UI looks like this. Since the clothes are still being washed, we don't have anything to hang yet, but that's okay. We still have more work to do while the washer runs because we have dry cleaning to take care of. How can we make sure the dry cleaning stands out so it doesn't get thrown in the washer by accident and also can easily be sent to the cleaners? Well, what if we add yet another check to see if it's dry clean only and give it a golden sheen if that's the case? And add a button to send it away. And if it's none of those things, we'll just leave it in the room outside the machine as we've been doing. So now our dry cleaning has a little sparkle to it, and we can send it away and hang our clean clothes to dry. Ta-da! So that's all well and good, but isn't our laundry template looking a bit cluttered? This is a component meant to be used by multiple users after all, but it doesn't seem very readable or usable right now because there's too many options. Jen Gaffigan voice, this component is trying to please everybody! And while sure, we can do it all with props and name slots, including a standard everybody's individual laundry preferences is not only too much work for this developer, but also a lot of upkeep. Wouldn't this component's purpose be clearer and less brittle if we focused on handling the most common use case of accepting everyone's laundry, and then each user or parents could handle their clothes differently as they see fit? But how can we do that? If you guess slots, you might be psychic and also on the right track. However, there is a slight wrinkle to that, and I don't mean the DOM kind. In our previous components, we started with an approach of the parent injecting visual content into the child via the template using slots. The child controlled the framing, and the parent controlled the data. But in our current use case, the parent no longer owns the data because it passed the content to the child via props in the script tag, not slot content in the template tag. In other words, from a template perspective, the parent currently has no say over the layout or content of its data in the child, and the division of slot responsibilities that served us thus far has shifted. Because the data is being passed via props, the child slotted component can mutate the content however it likes before rendering it, meaning that from the parent's perspective, we have no idea what the data looks like. To resolve this, we could certainly add slots to the child, essentially punching a hole in its ceiling so we can have an opening to pass visual content through. However, remember that now only the child has the data and can mutate it as it sees fit. So the parent has no way to know what the child has named the data, or whether it's been changed, and so on. In other words, if we just add slots to the child and stop there, the parent has no way to know how to access the data. This might seem strange because the parent technically does have access to the data, or at least an artifact of it, doesn't it? After all, how would the parent be passing data to the child otherwise? Remember, the issue is the child now has control of the data, so the child can change it however it sees fit. While it is possible that the child doesn't change the data in any way before rendering it, we can't really rely on that being the case. And at any rate, the compiler is much less adept at guessing than us clever developers. And anyway, who likes guessing about code? To recap, even if in theory both parent and child are referring to the same chunk of data in the same form, it's possible and even likely that they're referencing it using different names, meanings, and contexts. And so, in order to access the slots we've added to the child component we're sending data to via props, we're going to need a parent-child protocol or translator to access it. Now, if you're feeling confused by this, you're not alone. I was, and often am, still turned around by this too. In fact, I've linked to a podcast at the end where you can hear for yourself just how lost I get when it comes to this particular API, which, again, is scope slots. But don't worry, I've come prepared. While v4 lists are not the only valid use case for scope slots, they can be very helpful in highlighting what and why are scope slots. In our current context, we have a component similar to this one, a component that's going to render a list of items and contains one or more slots. At its core, a child with a v4 will grab each item in the list and render it regardless of whether it contextually fits the situation.
Thank you very much, and bye!
But what if we want to change an item's appearance or behavior depending on what it is or who's using it? Because it's the reason we've gone off on this tangent to begin with, it's probably safe to assume that adding a slot tag is not sufficient. Let's talk about why. Remember this example from the beginning of our misadventure where M replaced default JSON as a basic slot's content? Well, if we just add a slot to a list item in the template, guess what's going to happen? That's right, every single item will be replaced by M. So let's add in some additional control flow in the parent to analyze or at least grab each item, you might suggest. But the thing about v-for is, how do we know what variable name the child chose for each index in the list? It could have used item in items, or maybe robot in items, or even mutated the array with a computed property and now it's friend and friends. You get the picture. We need to find some way of standardizing the name by which the parent and child refer to the data in the slots template. And with scope slots, that way is something known as slot props. Here's our laundry code from earlier again, only now we've refactored it to use scoped slots. Let's take it one step at a time. First, in the parent on the left, we're still passing our laundry in via props to the child on the right. And we're still filtering out the machine washable clothes in the child, only this time, instead of filtering them out directly on the image tags to be rendered, we're sorting them into one of two slots, one named and one default, and providing the image as the default content. Going back to the v-fors, notice how in the child I'm grabbing each item by the variable name clothing item, which means that anywhere in the v-for tags I want to access each item's data, I need to do it using that clothing item keyword. And therein lies the key to accessing the list from the parent. We need to use that vbind directive on the child template on that clothing item variable. Once we've done that, whatever name we've vbound to on the left of the assignment is what we can call the item in the parent. But to access them in the parent, we need to define a name for them there too. Just like we did in the child, we can choose whatever name our hearts desire. In this case, I'm using slot props as is convention, but you might have noticed that slot props was nowhere to be found inside the parent template outside of that declaration. That's because I actually took this one step further and destructured that slot props object into the variable names we previously gave the items in the child on the right. Now, the syntax is doing a whole lot of work on both sides of this relationship, but to break it down, essentially in the child you want a slot tag, the name of the slot if there is one, vbind, the variable name you're going to use in the parent, and link it to the name you're calling it in the child. Then in the parent you need a template tag, the vslot directive bound to the name of the slot if it has one, and pass it a name or expression representing the name of the value in the child that you want to access. Once you've done that, you can augment and replace to your heart's content the template that will be rendered in the child slot using your chosen keyword. In a way, scope slots are a lot like the red room in The Haunting of Hill House. If you're averse to spoilers, I recommend temporarily muting this talk and focusing only on my speaker video. I'll give you a banana hand signal when it's done. If you've chosen to stay tuned, don't worry, it's not a scary scene. Otherwise, this is your final call to mute in 5, 4, 3, 2. So, the red room is a recurring mystery throughout the series. It's a room that everyone in the house can identify from the outside by its shiny red door, but no one quite knows what it looks like on the inside. Part of the reason for this is that the room mutates its form and function depending on who's using it. Similarly, with scope slots, we know what the outside or the framing of the scope slot component usually looks like, but its final markup can vary drastically depending on the user. So how can we possibly wrap up scope slots, the hairiest of them all? And further, how can we identify when we need them? My most important takeaway for you today is that scope slots are specialized for the intersection of pure JavaScript data and visual content. Unlike other slot types, with scope slots, the child contains both the content and the framing. So we need to establish some kind of translation key or legends to allow the parent to access and replace template data in the child. Slots might be apropos when you need a flexible and reusable component, such as a list that is usually text, but sometimes you need to add a button to it, or components that usually look and behave one way and therefore get their data through props, but have one-off exceptions. Finally, as with two of the other types of slots, the default or initial content is owned by the child and replaced by the content the parent passes in. However, in most cases, the data will still be owned by the child. Thinking back to this laundry-related visual from the beginning of the talk, how great would it be if we could combine teleport with scoped or other types of slots? Unfortunately, from testing out every combination I could think of, it seems that teleport destinations cannot contain slots. In other words, you can't, for example, teleport content into name slots inside the teleport destination. Although, I'm sure there's a way around that pickle if you're looking for a project to practice what we've learned today. And that brings me to the final section before we call it a talk? Will it nest? And for that, my short answer is yes, and my long answer is also yes, except maybe for teleport. To expand on that a bit though, generally slots can be nested. This also includes scope slots. However, in my View 2 experience, the middle slot in a nested scope slot situation may not work if you use the hashtag shorthand for vslot. Finally, with teleport, you can nest slots inside origin teleportals, as well as have all sorts of fun with nesting tricks involving destination teleportals. For example, nesting an origin teleportal inside a destination teleportal to forward teleported content to a second destination. But it seems like slots inside teleport destinations will be ignored at best and break at worst. My guess at the reason for this is that when you access a slot from a parent, there is usually a custom component wrapping that slot. But if you put a slot directly into a teleport destination and try to teleport data into it, you're bypassing that component wrapper layer. So I don't know about you, but I feel overwhelmed by how much slot content we've gone over in the past half hour. Let's review the key points to make sure we've got it. In general, slots are great for having consistent framing across multiple instances of a component, because the parent injects visual guts into a UI wrapper created by the child. We can organize slot content more granularly by using named slots, and if we want to restyle a child's template where we're passing the relevant data via props, we can use scoped slots. Teleport is great for placing elements in the DOM irrespective of inheritance. We can think of their destinations as components that are oblivious to the ephemeral shape of the UI, as places we want to send content we need to render no matter what. And remember, slots are generally superficial. For the purposes of this talk, we didn't cover $sign slots, which provide a way to access slot data in the script tag. And one point here I learned the hard way is that $sign slots is not reactive. Also, in View 3, $sign slots will output functions instead of objects, and scope slots, which in View 2 are their own thing under $sign scope slots, have been moved into $sign slots in View 3. If you'd like to read more about slots and UI reusability, here are some resources to continue your learning journey. This has been Punching Holes in the Sky, Mutating the DOM via Wrinkles in Space. Thank you all for listening, and have a fantastic Friday.